Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Management Studies, SOMS, Bachelor's Degree Programs, Bachelor of Commerce, BCOMG, BCOC 134 Business Mathematics and Statistics, Part A Business Mathematics. Unit 1 Introduction to Matrices. 1.0 Objectives. After going through this unit, you will be able to understand 1. Basic concept of matrix, 2. Types of the matrices, 3. Basic operations of matrix algebra, and 4. Transpose of a matrix. 1.1 Introduction. Matrix, matrices in plural, is an arrangement of numbers into rows and columns. Because of its features of I. Compact notation for describing sets of data and 2. Efficient methods for manipulating data sets, it becomes a handy tool for finding solutions to problems which can be represented in linear equation system. Needless to say, matrix algebra finds wide applications covering the fields such as engineering, economics and business, sociology, statistics, physics, medicine and information technology. For a better understanding of the applications, consider the following examples. Sociologists use matrices to study the dominance within a group. Demographers use these to study births and survivals. Industries and businesses take the help of matrices for fast and accurate decision making in the areas like evaluation of customers' preferences to produce and sell. Some use linear programming techniques that is based on matrix formulations of data to maximize profit and thus plan production or availability of raw materials. Use also is made of the matrices to arrive at a decision on the location of business, marketing of the products or arranging financial resources. Economists use matrices to examine inter-industry flows, for studying game theory and to construct the system of social accounting. Moreover, in medical studies, scientists use data in matrix form to determine a statistically valid rate of efficacy of a drug before prescribing it in hospitals and pharmacies. Many IT companies also use matrices as data structures to track user information, perform search queries, and manage databases. Definition: a matrix is defined as a rectangular array of numbers arranged in rows and columns enclosed by a pair of brackets with or. For example, the following array of numbers shows a matrix as. Look at the screen. On the basis of number of rows and columns that a matrix has, we decide its dimension or its order. By convention, rows are expressed first while columns second in a matrix. Since the above matrix has 3 rows and 4 columns, we say that its dimension, or order, is 3x4. The numbers that appear in the rows and columns are called elements of the matrix. In the matrix above, the element in the first column of the first row is IL, the element in the second column of the first row is 42. Following the same logic, we can identify the other elements. A matrix is usually denoted by a capital letter and its elements by corresponding small letters with 2 subscripts which indicate row and column. For example, an element represented as a 2, 3 in a matrix, is read as its to be position in second row and 3rd column. Thus, a matrix having m rows and n columns can be written as. Look at the screen. The above matrix can also be written as A is equal to age, mxn where I, indicating a mxn order matrix. 1st February 2001 Types of matrices. We will discuss the most commonly used matrices to be able to use these in business-related problems. Some other types will be taken up once we get familiar with transpose of matrix. 1. Rows matrix. A matrix which has only one row or a matrix of order IXN is called row matrix. 2. Columns matrix. A matrix which has only one column or a matrix of order MX1 is called column matrix. 3. Rectangular matrix. A matrix is said to be rectangular if the number of rows is not equal to the number of columns. 4. Square matrix. A matrix in which the number of rows is equal to the number of columns is called square matrix, i.e., the matrix of order mxn is a square matrix, if m is equal to n. 5. Diagonal matrix. A square matrix in which all the elements except the diagonal elements are 0 is called diagonal matrix. Square matrix A is equal to age is a diagonal matrix if age is equal to 0 for all. 6. Scalar matrix, a diagonal matrix in which all the diagonal elements are the same is called scalar matrix. 7. Identity matrix, unit matrix. A scalar matrix in which all the diagonal elements are 1 is called unit matrix or an identity matrix. An identity matrix is denoted by capital letter I. 8. 7. Triangular matrix, a square matrix is said to be triangular if all of its elements above the main diagonal are 0, lower triangular matrix, or all of its elements below the main diagonal are 0, upper triangular matrix. 9. Null or zero matrix, a square matrix in which all the elements are 0 is called zero matrix or null matrix. It is denoted by capital letter O. 10. Symmetric matrix, square matrix A, age, is a symmetric matrix if A times Lj for all ANJ. We will revisit this matrix after covering the transpose of matrix in this unit. 1.3 Matrix algebra. In this section we will discuss the basic operations of matrices. We start with the idea of matrix equality before taking up the operations of addition and multiplication. In matrix algebra, the elements are ordered numbers and therefore operations on them have to be done in ordered manner. It may be useful to note that while we deal with the main operations such as addition and multiplication, other operations viz. Subtraction and division are derived out of those. 1st March 2001 Equality of matrices. Two matrices are equal if the following three conditions are met. 1. Each matrix has the same number of rows. 2. Each matrix has the same number of columns. 3. Corresponding elements within each matrix are equal. The above conditions simply require that matrices under consideration are exactly the same. 1st March 2002 Addition and subtraction of two matrices. Matrices can be added or subtracted if and only if they are of the same order. The sum or difference of two mxn matrices is another mxn matrix whose elements are the sum or difference of the corresponding elements of the given matrices. For two matrices A is equal to A times, and B is equal to B each, mxn, where C is equal to E each, mxn and H plus or minus B each for all I and J. Negation of a matrix. The negation of a matrix A is denoted by A, which is obtained by replacing all the elements of A by their negation. 1st March 2003 Multiplication of matrix by a scalar quantity. If a matrix is multiplied by a scalar quantity, then all the elements are multiplied by that quantity. If a matrix A is equal to A times is multiplied by some scalar quantity, then e.g. mxn, large mxn. Properties of addition of matrices. 1. Addition of matrices is commutative if A and B are two matrices of same order, then 2. Addition of matrices is associative if A, B and C are three matrices of same order, then 3. Existence of additive identity if A is a matrix and O is the null matrix of the same order as that of A, then 4. Existence of additive inverse for any matrix. A plus GA is equal to GA plus A is equal to O. 1st March 2004 Multiplication of two matrices. Two matrices meet the requirement of multiplication if the number of columns of first matrix is equal to the number of rows of second matrix. If the matrix A is of order mxn, i.e., it has m rows and n columns, then matrix B must be of order nxp, where n is number of rows and p is number of columns, which is not necessarily equal to m. Then the product AB is another matrix C is equal to AXB of the order mxp, number of rows of A and number of columns of B. Let A is equal to age, none B is equal to IGNXP be two matrices. Then the product AB is the matrix C, where CLL, all bl plus times 12b21 plus al, ebmla. C12, at 1b12 plus b plus a 12b2p plus 01p, is equal to a 21 bil plus and b21 plus times 02i, is equal to a 21 1212 plus and b2 plus a 2 m2b plus and b2p plus 02p. CNL, and I blip plus and 2b21 plus 1c and 2b12 plus a, t2b22 plus blp plus b2p plus times. Remark, in the matrix product AB, the matrix A is called the prefactor and matrix B is called postfactor. 1.4 Transpose of a matrix. The new matrix obtained by interchanging rows and columns of the original matrix is called its transpose. Suppose we have a matrix A is equal to I times log order mxn. We interchanged its row and column. The matrix thus derived is known as transpose of A and denoted by at or A. For any matrix A and A are always defined but need not to be equal. In the above matrices A and A are defined but not equal because the order of A is 3x3 while the order of A is 2x2. 1.5 Summary. In this unit we have discussed matrices which help find unique solution to problems when expressed in equations of linear forms. The basic operations viz. Additions and multiplications have been taken up after introducing the concept of a matrix and types of matrices. We have seen that matrix defined as a rectangular array of numbers arranged in rows and columns. There are matrices such as row and column matrices, identity, diagonal, null, symmetric, rectangular, triangular and orthogonal. The unit closes with a brief discussion on transpose of matrix, which means obtaining a new matrix. Matrices like orthogonal and skew symmetric have been discussed in this part. Thank you, subscribe to our channel for more updates, and we will see you with the next chapter.